students, in this module we'll be discussing the HACCP quality systems. Going by the gist of it, firstly we'll be introducing the food safety and quality management systems. Then we'll briefly look into the history of HACCP. Then the main part and the main focus of it will be the principles of HACCP, that is hazard analysis and critical control points. There are 7 principles. We'll be outlining them later in the presentation. The implementation and maintenance of HACCP plan, comparison between HACCP and how it relates to ISO 22000, what are the benefits of HACCP to consumers, to industry, some limitations in the implementation. Now, what exactly is HACCP? HACCP stands for Hazard Analysis and Critical Control Point. It is a systemic approach to identify, evaluate and control the microbiological, chemical and physical contamination related to food safety throughout the food supply chain. The main idea behind this is to reduce the number of product compliance failures and recall, and thereby protect and enhance the brands and private labels. This will promote the consumer confidence and the products will conform to regulatory and market requirements. Basically, it goes on to the philosophy of earning the profit rather than making the profit. We have to reduce the number of product failures in the market so as to have more profit in the more competitive international scenario nowadays. Now we come to what exactly is a hazard. So a hazard is a biological, chemical or physical agent or the condition of food which has a potential to cause adverse health effect. It can be biological in nature, chemical, or it can be a physical agent which can cause illness or injury in case there is no control for this. So we come for what exactly is hazard analysis. Hazard analysis is the process of collecting and evaluating the information on hazards and the conditions of food which can lead to their presence, and then we decide whether they are significant for food safety and should they be addressed in the HACCP plan. Now we go in for what are the types of hazards. Now the hazards, as I said earlier, we can have 3 types. We have physical, chemical and biological hazards. Physical hazards, some examples are listed as follows. We have small stones, glass, metal pieces, straw, any other plant parts, etc. Chemical hazards, some examples could be excessive or toxic amounts of antibiotics, toxins, heavy metals, chemicals, pesticides, insecticides, additives, detergents and cleaning compounds. Also may be some residues which may be present in the food which can cause illness or injury upon consumption. Coming to microbiological hazards, some of the well-known examples of the foodborne pathogens could be Campylobacter, Enterohemorrhagic E. coli, Clostridium botulinum, Listeria, Salmonella, etc. Now we come to hazard analysis. Hazard analysis critical control point. It provides answers to 3 questions. First, what are the hazards that can enter the product? Where exactly in the entire food chain or the food processing section these hazards are occurring, and how we can control or eliminate these hazards. The benefits of this HACCP and the features are that it is a science-based, stepwise process, systematic approach for identification of hazards, for installing the preventive measures to eliminate or reduce the hazards to acceptable levels. It is a proactive approach rather than a reactive approach. HACCP follows a risk-based approach and does not rely on the end product testing, because it's better in the sense that there are chances that hazards may not be evenly distributed in the product and at times they might be missed in the sampling. There is a need for sampling large quantities, and in case the product is not compliant, it will need to be destroyed and reworked or may be reworked, and that means a lot of loss for the company. HACCP starts from the beginning of the process, right from the receiving of ingredients till the packaging and dispatch. It follows a process-based approach to the final product and shipping. Now, looking into the components, we have two major components in HACCP. Firstly are the prerequisite programs and the hazard analysis. Prerequisite programs, they are the foundation to the HACCP programs and include the good manufacturing practices. They actually lay the foundation and the base for the HACCP plan to actually function properly. So, we are in HACCP addressing the food safety right from the receiving of the raw materials till the shipping, and include even the indirect hazards in the process. Now coming to briefly for the PRPs, that is the prerequisite programs, they take into account the premises, the transportation and storage, the good manufacturing practices in such cases, equipment, personnel, the training, sanitation and pest control, procedures for recall, allergen control, supplier quality assurance, outside the property and building, how is the design, what is the construction, how is the building maintained, how is the lighting, the ventilation, waste disposal facilities, which areas are marked as inedible areas, what are the sanitary facilities for employees, the generation of hot water, ice, steam, the carriers for the food, whether temperature controls are there for receiving, storage and processing, the incoming ingredients, packaging, non-food chemicals and the storage for finished products. Coming now to the historical facts, a brief of the history of HACCP. Dr. H.E. Bowman from Pillsbury in 1960s, he was the one who was responsible for laying the foundation of HACCP, and the idea was that they needed more control over the raw materials, environment and people in the system as early as possible and come as close to 100% assurance that the foods are not going to be contaminated with pathogens. So, looking into the history, it started in 1960s and till 2018 it has come a long way. Coming to the history of HACCP, it was jointly developed by the Pillsbury Company along with US Natick Laboratories and NASA under the Zero Defects program to assure 100% safety for foods for astronauts to be used in space. In 1971, HACCP system was published and documented during the National Conference on Food Protection, USA. In 1985, US National Academy of Sciences recommended the use of the system for food safety, and the system was adopted by FAO WHO Codex Alimentarius. 1985 itself, the National Advisory Committee on Microbiological Criteria in Foods, NAMCF, recognized the HACCP based approach to food safety. In 1991, WHO endorsed the HACCP approach. The Codex Committee on Food Hygiene prepared a draft report on HACCP for Codex Alimentarius member countries. In 2003, FAO and WHO developed the HACCP guidelines, and in 2005, HACCP was actually integrated with ISO 9001 to formulate Food Safety Management Systems ISO 22000. Since the worldwide acceptance of Codex model has been there, it has resulted in a consistent format for developing and implementing HACCP plans in food establishments. Earlier in 1990s, there was voluntary acceptance of HACCP in US and Canada by the seafood industry, and later on it became mandatory in 1996 for the meat and poultry sector. In 2001, it was adopted by the processed juice sector, and now we hardly see any food industry without HACCP. Before we actually look into the principles of HACCP, let us look into the definitions of the common terms which are employed. So what exactly is a critical control point? A critical control point is a step at which the control can be applied and it is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. Then we come to critical limits, that is the upper and the lower value of the criteria which you have set for the control, that is the prescribed value of biological, chemical or physical hazard that needs to be controlled at the CCP to make the product safe. Then there is a CCP decision tree, that is a sequence of questions to assist in determining whether this control point is a CCP or certain alternative step needs to be taken as a CCP. Control measure is any action or activity that can be used to prevent, eliminate or reduce a significant hazard. Then is the corrective action. Corrective actions are the procedures followed when a deviation occurs in the process. Now what is a deviation? Deviation means that there is a failure to meet the required critical limit for a CCP. The critical limit has been either above the level or below the level and it is not acceptable, that is a deviation from the plan. Then HACCP plan is the written document which is based upon the principles of HACCP and delineates the procedures to be followed. Now is the HACCP system. HACCP system is the result of implementation of the HACCP plan. Then is the HACCP team, that is the group of people who are responsible for developing, implementing and maintaining the HACCP system. Hazard we have explained earlier also, but then again I would like to re-emphasize that a biological, chemical or physical agent reasonably likely to cause injury or illness in the absence of its control, that is if the control is not existing, the hazard can enter the food chain or the food process. Hazard analysis is the process of collecting and evaluating the information on hazards which are associated with the foods which are under consideration to decide whether they are significant and they need to be addressed in the HACCP plan. Monitoring means that you conduct a planned sequence of observations or measurements to assess whether the critical control point is under control, and also it is necessary to produce an accurate record for the future use in verification. The prerequisite programs include GMP, and that is good manufacturing practices, and good hygienic practices. At times they are overlapping, which address the operational conditions which provide the foundation for implementation of the HACCP system. Severity, that is in case the hazard is there and the loss in control is there, that is the hazard is present in the food, what is the seriousness of the effect, whether it is life threatening or it's going to have a short term effect, that severity needs to be considered while formulating the HACCP plan. Step is a point, procedure, operation or stage in the food system right from the primary production to the final consumption. Then comes validation. Validation focuses on collecting and evaluating scientific and technical information to determine whether the HACCP plan is properly implemented and will be able to effectively control the hazards in the process. Verification means those activities other than the monitoring which determine the validity of the HACCP plan and whether the system is actually operating according to the plan or not. Now we come to the principles of HACCP, which is a major part of this module. The first principle is to conduct a hazard analysis. Second, determine the critical control points. Third, establish their critical limits for the control which you are taking. Fourth is to establish a system to monitor the control of CCPs. Then establish the corrective actions to be taken when the monitoring indicates that CCP is not in control. This is very important. Then establish the procedures for verification to confirm that HACCP system is working effectively. Finally, we have establishing the documentation concerning all the procedures and records appropriate to these principles and their application. HACCP model consists of 12 steps, of which 5 are preparatory steps and the remaining 7 are the steps for implementation of the program, and there are logical systemic approach towards the entire processing of the food. Now, the first step is to assemble the HACCP team. This includes, of course, the chairperson, the production specialist, technical specialist, process engineers, other specialists like microbiologists, chemists, etc., and those people who are mainly involved in the processing in the various divisions of the process. And a very important aspect to be taken into consideration is the top management support, which is required for implementing, maintaining and carrying forward of the HACCP. They should ensure appropriate resources, manpower, training and the logistic support to the implementation of HACCP in the plant. Step 2 is to describe the product. Describe the product means we need to fully describe the product as to obtain the relevant safety information, and this will include the name of the product, the common name and the generic names, the composition, its packaging, the units of packaging, its shelf life, what are the storage conditions required for it, labeling instructions, special distribution conditions, maybe refrigerated storage or frozen storage or keeping in the dark. Then the actual use of the product, that is whether it is a ready to eat material, it is a raw material to be used for some purpose, or how exactly the product is to be used, how the product is to be sold, whether it is going to be sold in retail or it is packed for institutional purposes or for wholesale market, etc. So all the description of the product needs to be collected. Step 3 is to identify the intended use based on the expected uses of the product by the end user or consumer. What are the normal or common uses and whether any deviations are occurring in the consumption of that particular food product, where it is going to be product consumed and by whom, which are the segments of the population who are going to consume. For example, if the food is to be consumed by children or adults or the old population, geriatrics or infants, we need to be very clear regarding the food safety issues for each segment of the population. The step 4 is to construct the flow diagram. This flow diagram should cover all the steps in the operation for a specific product, including the preceding steps, that is the steps before this particular step. For example, in case powdered sugar is to be used, how the sugar is powdered, which are the machinery to be included, and the steps preceding and following the particular operation. It should be a simple, logical, step-by-step outline of the entire process for manufacturing of the food. All the key steps involved and the machinery and the people involved should be taken into consideration. This is very important for implementing the HACCP plan. Step 5 is the verification of process flow diagram. The actual operators should go into the plant to verify each and every step in the process flow diagram and include the modifications in case required. The 6th step is to conduct the hazard analysis. This has to be conducted at each step, and any measures to control the identified hazards need to be considered. This has 2 segments, that is identification of the hazard and its analysis. In the identification of the hazard, we need to take care of the nature of hazard, its characteristics, the previous safety record, the likely hazards which can occur in that particular step, the raw materials, ingredients, packaging materials, all the activities, operation, personnel involved, the equipment, the intended use of the product, how it is going to be distributed. The entire information needs to be considered for hazard analysis. We can consult appropriate sources of information, that is published data or previous experience, the likely occurrence, severity of the risk these hazards present, what are the impacts on short term consumption or the long term exposure of the hazard, of that particular hazard, population segments which are at risk if the hazard is present, the previous incidents and how they were tackled, all are considered under the hazard analysis section. Then we come to the identification of the control measures. The hazard analysis team must determine whether the control measures are existing for the identified hazards to be eliminated or prevented or may be reduced to an acceptable level. The next step is to determine the critical control points, that is, those points in the process at which the identified hazards will be controlled. Next is establishment of the critical limits for each critical control point. This critical limit is the criteria for accepting or rejecting a raw material or ingredient, which is the critical control point. It may be temperature, it may be microbial load, it may be color or any physical shape, etc. So let us see until so far how many principles we have covered. We have covered principle 2, that is determine the critical control points using CCP decision tree or any other tools. We have established the critical limits, that is it can be based on humidity, moisture, temperature, time or any other measurable parameter. Then is the establishment of monitoring procedures, that is to establish the monitoring requirements for using the results of monitoring to adjust the process and maintain the control. Then coming to the 9th step, that is establish monitoring system for each CCP, that is the principle number 4, whether the critical limits are being respected, whether there is a trend towards loss. In that case, we need to correct and rectify the loss of control, and in the requisite amount of time itself we are able to control the process. The procedures for monitoring need to be reliable and appropriate. The frequency of the monitoring must be specified. The skill and the training for the employees, the calibration of the equipment, all this must be ascertained by the team, and the records must be generated when, that is, what is the frequency of the record of monitoring and who is going to record. This is also going to serve as the evidence for the implementation of HACCP whenever any auditing is required. The next step is to establish the corrective actions. This takes care of the principle number 5. That is, in case any deviation in the process has occurred and a non-conforming product is there, which may be unsafe for consumption. So what are the immediate actions to be taken to take care of that non-compliant product? Find out the causes of deviation. We go by 5 W's approach, that is 5 whys, how and why this happened, to go for the root of the deviation which has caused the loss of control. We correct that cause, find out for how long the deviation occurred, which all batches have suffered and they need to be reworked, and how to actually tackle the non-conforming product. And we should assure that the non-conforming product should not reach the consumer. We need to keep record of all the actions taken so far. The next step is to establish verification procedures. That is, we validate to ensure that critical limits, the monitoring procedures and the corrective action procedures are actually capable of controlling the identified and necessary hazards. This system needs to be continuously monitored for being effective. There should be continuous review of the product and the program. The products should be periodically sampled and analyzed to verify the effectiveness of this program. The last step is to establish documentation and record keeping. This is very important for monitoring purposes, for installing the corrective procedures, the verification procedures and the HACCP plan development, and what all modifications need to be provided in the later runs. By far we have covered principle number 5, establish corrective actions, principle number 6, establish verification procedures, and principle number 7, establish record keeping and documentation procedures. Given here is an HACCP plan worksheet for apple juice taken from literature. As you can see, we are beginning from the growing of apples in the orchard till the end, that is in the factory aseptic filling and storage is occurring. From step 1 to step 12 we are taking the various hazards which can come, and the various hazards mainly they are biological hazards, that is molds or pests, and petulin, that is the aflatoxin which may be present, and good agricultural practices are mainly taking care of the molds and the pests. However, critical control point 1 is to remove the molded and damaged apple, and the critical limit has been established as that the visibly moldy apples should be less than 1%, and the corrective actions are to discard, and the record maintained will be at farm. The critical control point 2 is to remove the moldy apples from the factory when they are received in the factory, and less than 1% visibly moldy apples need to be discarded. CCP 3 is that while the apples are being washed in the factory, the petulin, that is the aflatoxin, should be leached out, and the rotten parts should be removed by pressure spraying, and the critical limits are the soaking time and the pressure by which water is going to be sprayed, and the monitoring procedures, that is the time of soaking step, pressure of this spray that needs to be monitored, and corrective actions are to repeat the washing step, and the records need to be maintained. Likewise, CCP 4, that is the storage of apples. What is the storage temperature? Less than 10 degrees centigrade or less than 48 hours in the store. And CCP 5 is the size and quantity of particles which are remaining in the pulp. So, these are the various CCPs in the apple juice manufacture, and this has been taken from the literature. Likewise, some more examples are given in the form of milk processing, that is we have 2 CCPs, that is in the CCP 1 in the raw milk we are taking care of antibiotics or pesticides, and CCP 2 is the pasteurization temperature and time. Similarly, in honey we can have pesticide or antibiotic residues or hair and plastic, and they have been taken care by in different process steps. Then we come to look into the relationship between HACCP and ISO 22000. ISO is International Standards Organization. So, HACCP we have seen that it was developed by Pillsbury Company, whereas ISO 22000 system has been developed by ISO, and it includes other management system processes apart from HACCP and the prerequisite programs. ISO 22000 is an auditable standard and is recognized internationally, and it includes HACCP in its entire process, whereas HACCP is an in-house food safety management system. Now we come to what are the benefits of HACCP. HACCP instills consumer and customer confidence. It maintains and increases the access of the product in the market. It improves the production control process, reduces the costs by reducing the loss in the product and reworking. That is, you are earning the profit, not making the profit. Next is increased focus on food safety and the ownership of food safety in the entire plant, because all the people involved in the production process are involved in the insurance of food safety. Then business liabilities are protected, the product quality is improved, it is more consistent, and the inspections are also simplified because all the record keeping and documentation is already in place. It is aligned with other management systems, that is ISO 22000, which is quite a norm nowadays. However, there are certain limitations of HACCP also. The limitations are that HACCP requires resources. It requires technical, human and material resources which may not always be available for the company, and requires sincere effort and involvement of all the elements in the organization. It demands time and requires a change in the attitude towards production. Technical detailed data is required which needs to be constantly updated. It requires conserving the information in a simple way for interpretation, and concerted efforts from all the participants in the food chain is required. Now we come to what are FSMS, GMP, GHP and GAP. FSMS is Food Safety Management Systems or ISO 22000, which is a holistic system of controls that manage the food safety in food business to control and manage food safety in food business. It includes in its elements good hygienic practices. HACCP is included in ISO 22000. It is also having the management system elements, the policies, traceability or recall systems. Good hygienic practices and good manufacturing practices are set of practices which should be followed at all stages of the food supply chain so that HACCP is properly and successfully implemented. GMP is more for supplier control and specifications, the calibration of the equipment which are involved in the food processing, the traceability systems, recall procedures, the equipment designs, etc. Whereas good hygienic practices are more for the personal hygiene, employee health, maintenance of plant equipments and hygiene, that is the food contact surfaces, pest control, waste disposal, water quality, etc. Good agricultural practices are more for the on-farm practices to manage the food quality. So now we come to quality management systems. Quality management systems are well-defined procedures to be implemented to enable the organization to satisfy the needs of the customers, the current needs and the projected needs in the future. Management systems like ISO 9000 and ISO 22000 are available and they are implemented in the market. Total quality management has a broader scope than HACCP and may be covered in some other module. In this table, we give a description of ISO 9000 series. ISO 9000 system has 8 quality management principles: customer focus, involvement of top leadership, involvement of all the people in the chain, process based approach, systems approach to management, continual improvement, factual approach to decision making, and mutually beneficial supplier relationships. They serve as guidelines for selection and use, and the fundamentals and definitions of quality management systems are there in ISO 9000. ISO 9001 are the quality systems and they are recognized through independent registration processes. They serve as model for quality assurance in design, development, production, installation and service industries. ISO 9004 are having the guidelines for performance improvements. They serve for effectiveness and efficiency of organizations. They go beyond the quality management systems, that is ISO 9000 systems requirements, and beyond are specified in ISO 9004. Certain tools for microbial risk assessment have been specified and adopted by Codex Alimentarius Commission and other international bodies, which provide structured way of identifying and assessing the microbial risks in food. Again, they are based on hazard identification, characterization, exposure assessment and the characterization of the risks. Various software tools are available for microbial risk assessment like risk modeling softwares, predictive modeling tools, tools for specific risk assessments, etc. And the students, they are advised to have a look at these websites for more inputs regarding these. So friends, we have seen that a number of food safety and quality management systems are available for use. That is, for basic safety, we have the prerequisite programs, good agricultural practices, that is GAP, good manufacturing practices, GMP, and the GHP, that is good hygienic practices. For advanced safety, we have hazard analysis and critical control point. Integrated food safety management is taken care of by ISO 22000. ISO 9001 is the basic quality management systems. The advanced quality management systems are available in ISO 9004 series. Then we have ISO 22000, that is the food safety management systems. Microbiological risk assessment is one of the most significant recent development in the food safety management and provides a structured way of identifying and assessing microbial risks in the food. The effectiveness of the individual and integrated or advanced food safety and quality management systems depends on the identification and analysis of the factors present on the site. An intelligent selection procedure is therefore required to increase the effectiveness of an individual and integrated or advanced food safety quality management systems with continuous monitoring of the performance. Thank you so much.